I wasn't going to talk about board games, so, but maybe I will now. Hopefully, everybody has some kind of idea of what artificial intelligence is, and we're going to today talk a little bit about that. A few different definitions, a few different interesting uses of artificial intelligence, and I don't want to spend a whole lot of time defining all of these things, but I'll show you a couple of different lenses that I've found interesting, and maybe share a little bit of some of the fears and maybe hopes that we might have for artificial intelligence. But to start, and I'll just want to echo what Karan said, there are loads of people around our organization and around the world that have contributed to this kind of thinking. So I want to thank a lot of the people that did contribute to that and did help us to create all of these things. So hopefully you'll find some stuff interesting in here. One of the places that I'd like to start is to say, well, if you think about artificial intelligence, if you're like a lot of people, you might be really terrified as to where this whole thing is going. Like Karan said, most of our industries are going to be affected by AI in some way, shape, or form. And I think some people might be going, well, maybe I can just ignore it for a bit, and maybe I'll retire before the AI takes my job. But actually, for a lot of us, that we're not going to have that kind of we're not going to be able to do that. So you may be terrified as to where AI is going. And one of the things that might have contributed to that is the thinking around what AI is actually going to be doing. So about a decade ago, about 10 years ago, I picked up a book called The Singularity is Near. Has anyone heard of or seen or read that book? Anybody? Okay. So I was probably in equal parts inspired and terrified when I read that book. And there are a number of reasons, and I'll talk a little bit about it as we go through. So what The Singularity is Near suggested, and it was written by someone named Ray Kurzweil, who's some people might think of him as a bit of a crackpot in terms of the sorts of stuff that he's doing. But he's still extremely relevant. He's the sort of guy, he's working with Google at the moment in a division that has created a lot of the things that you're seeing on a day-to-day basis. And one of the things that he suggested was that at some point there's this idea of a singularity, which, depending on how you interpret that and the kind of data points that he's bringing together, you might take something different out of that. So who here has heard of the singularity? Right, what does the singularity mean to you? What does it mean to you? Go ahead.
It means I want to go to that nice thing that they have in Joburg called the Singularity University, and I'm going to be
Okay, good.
Exciting and neat.
Anybody else?
When computers have the same intelligence as humans.
Sure, and maybe to some extent it's where computers might overtake humans. And if you look at, this is a sort of exponential nature of technology, and they often call it the technological singularity. And that's the idea that at around about here, computing power overtakes all of human capacity. So one computer will be better than all the humans in the world. Okay? And this is not that far off. This is sort of 2045 is the year that they're suggesting that this may well happen. There are various interpretations as to what that means for us. One of the interpretations of people is that, well, that means that computers are going to take over. You're thinking Skynet, you're thinking Terminator 2, they're basically taking over the world. However, Ray Kurzweil goes to great pains to point out that actually it's not going to be one or the other. Like Karan was talking about earlier, it's kind of a man loves machine. It's more of a symbiotic relationship, and we're going to be working with the machines to try and create something that's better than the sum of the parts. So there is going to be this kind of, we will use the good parts of whatever comes from the machine, and we're going to use that to kind of improve what we're trying to do at the moment. So generally, there are different ways of thinking about the singularity, and generally there are different interpretations. But this is something that is definitely this idea that computing power is doubling all the time is actually what's driving that thought that computers are catching up to humans. And we're seeing this in things like the hype cycle here, where we're talking about a number of different pieces of research that are coming to the fore. And if you've probably seen this kind of curve before, at the top of the peak there, that's the highest level of hype that a particular technology might be receiving. And at some point, it's going to drop down into this trough of disillusionment. That's my favorite phrase of this chart. But at some point, it's going to reach this plateau of productivity. And that's where we will be able to use these technologies to help make our lives better. And one thing that you'll note, so if you look at things like autonomous driving, and there's a lot of talk of autonomous driving coming into everyday life, this still suggests that that's actually quite far away. So before that reaches that level of productivity, it's not, a lot of it's just conceptual, or a lot of it's just prototyping. It's going to become our reality, and as I showed on the previous slide, these things become more and more exponential. It's not just about computing power, there's a lot of different areas of technology that are becoming exponential, and therefore these things will come out at an increasing pace. So a lot of those things that are up there, you'll notice things like machine learning and deep learning, that are things that we'll talk about a little bit today, and those are all going to be coming to our industries in the next couple of years. So as I said earlier, we've borrowed some material and some slides from some of the people in this room, and this I thought was a really neat way of talking about, well, what is artificial intelligence, and what is this machine learning thing and deep learning and all of that? So when you look at artificial intelligence, what does that actually mean to you? I mean, I guess you could interpret that as, well, it's machines doing intelligent things. And as you can imagine, that's quite a broad idea. And a lot of people talk about artificial intelligence as the thing that's going to, revolutionize our industry or whatever. But we need to get a lot more granular, very quickly, right? So we need to start talking about what are the specific things that are going to be helping us, and how are those things going to help us. I would suggest that depending on what kind of job you do or what kind of work you're doing, you may think of AI in a kind of different way, right? So depending on whether you're the person making the program, or whether you're just the person talking about it, like me, in PowerPoint, it depends what it is that you're actually talking about. And I think, like we found with things like digital, the word digital was used in many different ways, but it becomes a useless term at some point. You have to start talking about the individual pieces that make up that particular concept. So how do we do that? Well, I really don't want to do an academic lecture or anything, and we can talk about a number of these specific items, but I thought it's interesting to show you that there are various aspects to AI that are all going to be relevant for us. Interesting thought was that actually what this is showing us is what AI is trying to do is reflect what humans can do. And so if you think about, looking up here, speech recognition and NLP are about trying to allow computers to have conversations, to be able to either talk to us, understand what we're saying, to be able to understand the meaning and the themes behind what we're saying. And then deep learning allows us to do a number of things, like try to understand what we're looking at and interpret those, things like object recognition. And then on this side, in the symbolic learning space, we're talking about robotics, so that's moving around like humans. Computer vision, again, comes in that space. So there are lots of different areas, and as you'll see today, there's some parts of AI that we are putting specific offers towards. So one of the areas that I found quite interesting is computer vision. And I'll come to that in a second, but in terms of machine learning, this is probably all we need to know in terms of the definition, is that it's a field of study that allows computers to learn without being explicitly programmed. So we're not telling you exactly what you need to do, but it's allowing you to learn as you go. And there are different ways of learning, we'll talk about that in a second. So one of the areas that I'm interested in is computer vision. And what is that? That means we're trying to allow a computer to see And it's an interesting quote from one of the key researchers in this area is that vision begins in the eyes. So that is, it's actually quite an easy task to get a computer to see things, because that's really just optics, right? It'll see all the things that are coming in. But actually where it truly takes place is in the brain. So we've now got to try and get the computer to reflect what is happening in our brains. And we're doing that in various ways. We're teaching the computer to be able to identify things, and then what is the implication of those particular things. So the context. The object recognition is only one thing, but actually what does that then suggest is going to be even more important. And for our industry specifically, that's going to be interesting. So often when people are talking about deep learning, all they really mean is neural networks, right? So there are different types of neural networks. We're not going to go into the detail now, but it's not a new technology. This is not something that's just come out in the last few years. When I started my career, we were already talking about neural networks. Can anyone here say why neural networks didn't take off in the 90s? Why didn't we, all start using neural networks back in the 90s in market research?
Computing power.
Cheap computational power.
Right. So computing power, absolutely. However, there was still people doing some neural network work. Right, so I'm sure some of you would have seen some of that back in the 90s and 2000s. The problem with it was when you got the result, quite often it didn't make any sense to us. It would tell us, this is the rule. This person is a high risk of defection. It would tell us that, but we wouldn't understand why. And at the time, we didn't have enough diagnostics to be able to try and help us with that. And that's a kind of a theme for me here, which we'll come to. But the neural networks now, because of computing power, are a lot better, and we're also building them with ways to understand what that means and how it impacts what we should be doing. So classification versus prediction those are the two kinds of ways that we would tend to use neural networks. Is we want to classify people, and that's one of the things we do a lot in market research, is try to work out if someone is an opportunity or risk or whatever. That's all classification. But then also we want to get into prediction. So those are the two spaces that neural networks and deep learning specifically can definitely help us. We've been using it a lot in social media. So this is one of the things Kara mentioned earlier. And you can imagine how classification and prediction are both being used in social media, trying to understand from what a person is saying online and on their social media to try and understand a little bit more about them and to be able to predict what they're going to be doing. So those are the kinds of areas that we can use a lot of our AI. Various types of machine learning. So again, I'm not going to dwell on these things, but there are various different ways that we could teach a machine to learn. And I'll give you an example just to make those a little bit clearer. So supervised learning means we tell the machine what the answer is. Okay, so and this is quite often in image recognition, which is why we're showing you here, where you will, like you're trying to train a kid, and you're saying, this is a car, this is an apple, whatever. That's kind of what we're doing with the machine, is we're saying, this is what the answer is, now see if you can identify it in other situations, other contexts. So this needs a big learning data set, it needs the algorithms to try and learn all those things, and then you need to try and verify it. And so that's quite often where you'll see AI being used. But an interesting space is unsupervised. So this is where we don't tell the computer what the answer is, but it kind of works it out by itself. So in this situation, we've shown, it starts to put things together on this map based on which things, which ideas, which words kind of occur together. Okay, so it looks at a whole bunch of data, social media data, for example, and it will say, okay, these things tend to group together. And the computer's doing that, and it then can infer some of the meanings of things and how those things fit together. So this, you've probably seen these before, supervised, unsupervised. But one of the interesting things is how we can transfer learning, because I think that's where we as pragmatic market research people will want to try and generalize a lot of the things that we're doing. So what does that mean? We're trying to take some learnings that we have in one space and we're trying to apply it into other spaces. So you might go through a kind of stepwise where you create this sort of model in one category or one area, and then you might want to do a small sample in another category, and then say, okay, now can we combine the learnings from the one with the other to try and generalize it a little bit or bring it into that specific new category. So that's where you come into transfer learning, which is going to be what allows us to kind of keep pace with this. So we don't have to do a whole big learning exercise every single time. We get to take some of the learnings that we have from one category and bring them into another. And then reinforcement learning is basically you tell the computer what you're trying to do, and then it needs to work out how to do it. So it does that through doing the thing again and again and again. And in this very sort of simple, conceptually, a simple idea is, can we teach it to play games? Can we say, well, how do you get over this? And then it's going to have certain actions available. It's going to try combinations of those. And it does it thousands and thousands of times. And eventually it works out, oh, okay, this is how I do it. And it starts to learn. So a lot of people might have heard as soon as you start talking about AI, you will go into AlphaGo. Has anyone heard of AlphaGo? Right, so see some nodding heads. Go is one of the oldest board games, and it's quite complex. So it's even more complex than something like chess. So a few years ago, there was a computer program that beat one of the chess masters. They now, 2 years ago, they made AlphaGo, which actually beat one of the Go masters. Now, that in itself was quite a big deal, and it was using a lot of the sort of machine learning space. And then almost immediately after that, they made something called AlphaZero, which beat AlphaGo. And it beat it not by studying all of the games that have been played, but actually just doing this, just learning from scratch. And it just, from every time it played AlphaGo, it learned. And then it learned, and it learned. And then within a very short amount of time, and I can't remember exactly how long, but it was, within weeks, it learned how to beat AlphaGo, and now will never lose to AlphaGo. And AlphaGo beat the best Go player in the world. So it's a very interesting way of getting into learning. And then deep learning, the only thing we really need to know about deep learning is that there are multiple kind of layers. So very simplistically, we're saying, well, a simple neural network, you put your input is the red on the left side, and then you put stuff in there, it looks at different combinations, and it comes out with something at the end. Deep learning has multiple layers, and there are different kinds of ways that you can do deep learning, but that's essentially all we really need to know. So that brings us to how do we, thinking about all of this stuff, how do we think about what needs to happen with AI in our industry and in other industries going forward? So are there some principles that we should be abiding by when it comes to creating AI? And one way that you could think about it, this Asimov's 3 laws of robotics comes from many years ago. It was published in iRobot, which was 1950, but actually the ideas of programming robots with safeguards or ways that we would stop them from harming humans comes from the 1930s. So is it as simple as going, well, there's some rules that the computer can never disobey and then we'll be safe? Well, unfortunately, it's not as black and white as that. Has anyone heard of the moral machine? Yes. So the moral machine, I've seen a few more nodding heads. The idea is, and this is something that I encourage you to go and take a look at if you haven't looked at it before. It's called Moral Machine. It's a very quick sort of survey that you can do. And it shows you these scenarios, and it says, okay, so if you were in this situation, and there are people on both sides, and you're the autonomous car, do you go straight through or do you swerve? If those were your choices, what do you do, right? And if you swerve, you're going to hit these people, but if you go straight, you're going to hit these people. So when you go through it, and it's really interesting what it does, is by the end of it, it then says, okay, well, here are some of your biases. Because you are more likely to knock over old people, or you're more likely to knock over dogs, or you're more likely to be a rule breaker, so you'll go through red lights instead of going through all the green lights. And so there's very interesting stuff that comes into it, and thinking about, this is not a dichotomous, well, kill people, don't kill people. It's actually, there's some decisions that a robot's going to have to make where it's not that clear. So I find this fascinating, and I think it's not as simple as going, don't hurt anyone. Sometimes you have to make more gray choices than that. So thankfully, in market research, we're not going to have to worry about this as much. However, there's still some things that we should be keeping in mind, I think. So firstly, I think the idea that we do no harm, that our AI does no harm, is absolutely going to be part of it. And that harm doesn't have to be bodily harm. It can be that we put someone's data out, that we have to take good care of their data, make sure that it's secure. So that's going to be absolutely something that we need to be thinking about when we're creating our AI. So that's kind of a no-brainer. Also, we should be designing them for human moments first, because that's really what this is all about, is that we're trying to create for the humans and then evolve that over time. So we make that experience better. It's not about saying, oh, this is this cool technology, you have to use it. It's about saying, well, we understand this particular humanness that you're looking for, and this particular moment that you're trying to enjoy, and here's how we can make that better. So it's about making that, making people's lives better rather than just using your technology. And then there's an idea around fairness and the desire to make life better, which is related but slightly different. So here, taking cognizance of people's time, their energy, and their money, and making sure that your AI is proportional to them. So you don't want it to be onerous in terms of what the person needs to do, and to detract from the experience that they're actually having. So that's something that you need to be thinking about. And then the last principle that we're trying to develop is around transparency. So this is about, it talks a little bit to the point that I made earlier about diagnostics. It's saying, when a machine is doing a specific thing, I need to know why it's doing that. Or at least I need to have some kind of idea as to the reasoning behind why it's doing a specific thing. So why it thinks what it does. So an interesting example around this was, there was an image recognition program that was created that was trying to, and I can't remember exactly why it was looking at dogs and wolves. Does anyone know that example? So it looked at a picture and it said, this is a wolf. But actually, any human looking at it would say, well, that's not a wolf, it's a dog. So why was it doing that? And the reason that they found eventually, after loads and loads of time they had to create a whole new program to try and work out why the program was doing this, they couldn't work it out. And eventually they found that actually it was just the fact that that dog was in snow. So there was snow around it. It was a husky, and there was snow all around it. This was the first picture that the computer had seen where there was a dog in snow, because all the wolves that it had ever seen were in snow. So something as small as that, you couldn't work it out with the first build of this program. Having those diagnostics is really important, and that's what really around the transparency of it, being able to understand exactly why it's making that decision is going to be important to trusting and adopting those particular areas. Okay, so I think I've talked enough. That's coming back to Karen's point earlier. It's not about man versus machine. It's not about us or them, or fighting off the killer robots. It is about us kind of working together, and it is about it all coming together. And part of that is around some of, you'll see how we keep the human in the loop in a lot of the work that we're doing within Kantar. There are a number of different offers that we have that are leveraging aspects of what we've been talking about today. And thankfully, we have some experts here that are going to help us talk a little bit about some of what we're doing within Kantar that leverages this. Thank you very much.
Thank you. Any questions for Adhil before we move forward? You are.
It's difficult. You present this wonderful moral framework, but as soon as you go out into the real world, I mean, if I start to think about safety and protection, I'm thinking about safety and protection of me and my family.
Yeah.
And a company were thinking about protecting their business.
Yeah.
those moral frameworks instantly evaporate, don't they? Once you start then thinking,
Well, I'm not sure that they evaporate, but I would say it becomes a lot harder. And I think that you're right that a company is going to be hard pressed to be thinking about the consumer all the time. But that's kind of what we're suggesting, is that we as an industry should be pushing people to be always thinking about the consumer and protecting them rather than just protecting ourselves. So I think we're wanting to lead from the front with this and be able to say, well, these are principles that we're incorporating into all of our now. And I think it's going to be very difficult to say everybody has to do this, but at least we can push them in that direction.
Any last ones?
One of your last slides, I think it was number 1, was about mentioned the point about accountability.
Yeah.
And it's a bit, for me, it's a bit linked into your number 4, which was about how we gather data and the data we use to train AI and things like that. Any further thoughts on practically how we keep AI accountable? How we, how we make sure that we're always we have a North Star that we're always using to shape it in a way so that it helps us to make decisions which don't harm, I guess.
Yeah, it's a difficult one, and I think that it is tied into what John is saying here. And I think as a research industry, the research bodies are going to have to try and take a role in that. But because we're seeing more and more people from outside of the research industry trying to create technologies, it's not going to be something that's easy to control. So I think companies like Kantar are doing a lot to try and make sure that we're all building within the same kind of framework, and other companies are going to have to try and do that too.
Cool. We're going to run out of time if we don't move forward.
Okay.
So thank you, Adhil. I think
Thank
it was
you.
very, very